Welcome to lesson number 4. We're going to be looking at forming equations and intercepts from the vertex and a point. We're going to be following this procedure in order to determine the equation if we're given the vertex of the graph as well as a point on the graph. So step 1, we're going to replace P and Q with the coordinates of the vertex. Step 2, replace X and Y with the coordinates of the point. Step 3, we'll solve for our A value. And then we'll plug all our values back into our equation. So I know that seems like a lot at this point, but let's see how we would get started here. So the graph of a quadratic function has a vertex of -2 and 8. So my vertex here is -2 and +8. So 5, 6, 7, 8, somewhere around here. And we know that it passes through the point of -1 and 7. So it passes through the point of -1 and +7. So this should be a little bit higher there. We pass through this point on our graph. Now, we want to find the equation of the function in standard form. Now, in standard form, what we need to do is fill in the information that we have. So we know that our vertex is equal to -2 and 8. Remember that these correspond to our P and Q values in our equation that's in standard form. And we also know that we have a point of -1 and 7, and these are our X and Y values. So let's plug this into what we know of our equation. So the first thing we know of our equation is Y is equal to A X minus P, which is -2. So -2 would be +2 squared and a +8 as well. Now my next step is using this equation and substituting my point -1 and 7 for my X and Y values. We can solve for A. So Y is equal to 7, X is equal to -1, and we can now solve for A. So 7 is equal to A. -1 plus 2 is 1 squared plus 8. 7 is going to be equal to A times 1 squared is just A plus 8. And if I subtract 8 from both sides of my equation, 7 minus 8 is equal to -1, which is equal to my A value. So this equation is going to look like this. Y is equal to -x plus 2 squared plus 8. And so then we could draw this on our graph. So let's see if we look at our graph. Oh, actually, let's look at the rest of the equation. So rewrite the equation in general form. Y is equal to ax squared plus bx plus c. So here's my original my standard form equation, -x plus 2 squared plus 8. In order to get this into general form, what we need to do is expand this term here. This is going to be -x plus 2 squared is x squared plus 2x times 2 is 4x plus 2 squared is 4 plus 8. If I take these out of my brackets, I'm going to be left with -x squared minus 4x minus 4 plus 8. And so in simplified form, we're going to be left with -x squared minus 4x positive 4. And now what we want to do is we want to sketch this graph using a graphing calculator. So -x squared minus 4x plus 4, and then we will graph. So this is what the graph of my equation looks like. It has a point going through there, and this looks like it's 1, 2, 3, 4, 5, close to 5. And opening downwards because it's negative. Now, in that last question, we want to determine the x and y intercepts of the graph of the function. And so we're going to use our graphing calculator here. So my x-intercepts. And we know, and okay, yeah, let's look at our x-intercepts. So go back to our graph, And I'm going to go to my trace function, and I'm looking at my zeros. I know that my zeros are equal to my x-intercepts. And so here I do my left bound as well as my right bound, and then I got to guess where I think that x-intercept is. I think it's around here, around 0.85, and it happens to be at 0.83 if I round to the nearest hundredth. So 0.83 is one of my x-intercepts. But if I look at my graph, I also have one in a negative position in my second quadrant. So let's go back to this other side of my parabola and see what this x-intercept is equal to. And again, I did my left bound, right bound, and then my guess, and it's about negative 4.83 to the nearest hundredth. So negative 4.83. Those are my x-intercepts. My y-intercept, if I look for my intersect function, I'm gonna again do my left and my right, and this is looking for, sorry, that's the wrong function. Let's use my my value. So I know that for my y-intersect, my x value is going to equal 0. Plug that in, and my y-intersect is equal to 4. Now with class example number 2, we want to determine as an exact value the x and y intercepts of the graph of the function f of x is equal to 3x minus 1 squared minus 9. And we want to do this algebraically. So remember, whenever we're looking for our x-intercepts, if we're looking for our x-intercepts, then y is always equal to 0. Okay, and it'll be the other round when we're looking for our y-intercepts. But if y is equal to 0, then we would have 0 is equal to 3x minus 1 squared minus 9. And if I expand my function here and solve for x, so 9 is equal to 3x minus 1 squared. And I kind of skipped a step there. I added 9 to both sides of my expression. So this 9 I brought over here, and I'm going to divide by this 3. So I'm now going to divide by 3 on both sides of my equation and bring this 3 over here. 9 divided by 3 is equal to 3, and I'd be left with x minus 1 squared. So one thing I could do, we're looking for exact values, so they want us to use radicals here. I'm going to square root both sides to get rid of this exponent. So square root this side of my equation 2, and I'll be left with square root of 3 is equal to x minus 1. Now, I need to bring this 1 to the other side of my equation. Remember, because I squared this is going to be plus and minus 3. And now I'm going to add 1 to both sides of my expression, and I'll be left with 1 plus or minus root 3 is equal to x, my x-intercept. Now for my y-intercept, x is equal to 0. And so I do the same thing I just did. Y is equal to 3, but instead of making y equal 0, this time x is equal to 0. And I can't bring anything to the side of equation because that's what my y value is equal to. So I need to solve y is equal to 3 times 0 minus 1, which is negative 1, or negative 1 squared is 1 minus 9. And y is going to be equal to 3 minus 9, which is negative 6. So my x-intercepts are equal to 1 and plus and minus root 3. And my y-intercept is equal to 6. Next we have class example number 3. We have a graph of a quadratic equation shown, and we also have the maximum point that's shown, and the maximum point's at negative 1 and 2. We want to find the equation of the function in standard form. So in standard form, we want to know that y is equal to a times x minus p squared plus q. Now, there's some information that we have. Even though it doesn't say outright what the vertex is, our vertex is equal to our maximum point, which is -1 and 2. And we also have a point on the graph, and the point on the graph is -3 and 1. So remember, this corresponds to our P and Q values. So P and Q, and this corresponds to our X and our Y values. So Y is equal to A X plus 1 squared plus 2. And if we want to solve for point A here to get our equation, then we substitute x and y into our equation. So y was 1 and x was -3. So 1 is equal to A, -3 plus 1 is -2, and -2 squared is 4. And if we simplify, I'll have to subtract 2 from both sides of my equation, and I'll be left with -1 is equal to 4a. And now I'll divide both sides of my equation by 4, and a is equal to -1 over 4. And so if we plug that all back into our equation, y is equal to -1/4 times x plus 1 squared plus 2. Next, we want to algebraically find the x and y intercepts of the graph, and we want to answer as exact values to the nearest hundredth. Okay, to the nearest hundredth, exact values. So just like we did up top, our x-intercepts, y is going to be equal to 0. And so 0 is equal to -1/4 x plus 1 squared plus 2. The first thing I'm going to do is subtract 2 from both sides. And so this will be -2 is equal to -1/4 x plus 1 squared. And then I'm going to multiply both sides by -4. So if I multiply this by -4, this will get canceled out. And if I multiply this by -4 times -4, this will be left with 8 is equal to x plus 1 squared. And then I'll take the square root of both sides of my equation, and I'll have the square root of 8, which is plus or minus, is equal to x plus 1. And finally, I'll have to subtract 1 from both sides of my equation, and my x-intercepts are going to be -1 plus and minus square root of 8. And exact values, this 8 can be broken down. So what we're going to have is this x is equal to -1 plus and minus 4 times 2, or -1 plus and minus 2 root 2. So this is my x-intercepts, and my y-intercepts when x equals 0. And so if x is equal to 0, then y is equal to -1/4, 0 plus 1 squared plus 2. And if we solve for y, we're going to be left with -1/4 times 1 plus 2, or y is equal to -1/4 plus 2, or y is equal to -7, or actually +7 over 4. Lastly, we want to state the domain and range of our axis of symmetry. So domain is an x is an element of real numbers. So if we look at our graph, any value of x can be placed on our graph. However, again, if we look at our graph and look at our maximum point, our range tells us that y has to be less than or equal to 2.